Hello, students. I'm B. Sankaralakshmi, working as an assistant professor too at the Department of Artificial Intelligence and Data Science in Ramco Institute of Technology. In this video, we are going to continue our learning distributed computing. The subject code is CS3551. Let us enter into this video. In this video, we are going to discuss models of deadlock. The models of deadlocks are explained based on their hierarchy. The diagrams illustrate the working of the deadlock models. PA, PB, PC, PDAR passive processes that had already acquired the resources. PE is active process that is requesting the resource. Single resource model. A process can have at most one outstanding request for only one unit of a resource. The maximum out degree of a node in a weighted for graph for the single resource model can be 1. The presence of a cycle in the WFG shall indicate that there is a deadlock. The following figure explains that. AND model. In the AND model, a passive process becomes active. That is, its activation condition is fulfilled only after a message from each process in its dependent set has arrived. In the AND model, a process can request more than one resource simultaneously, and the request is satisfied only after all the requested resources are granted to the process. The requested resources may exist at different locations. The out degree of a node in the WFG for AND model can be more than 1. The presence of a cycle in the WFG indicates a deadlock in the AND model. Each node of the WFG in such a model is called an AND node. In the AND model, if a cycle is detected in the WFG, it implies a deadlock but not vice versa. That is, a process may not be a part of a cycle, it can still be deadlocked. And the following figure explains that. Next one is OR model. A process can make a request for numerous resources simultaneously, and the request is satisfied if any one of the requested resources is granted. Presence of a cycle in the WFG of an OR model doesn't imply a deadlock in the OR model. In the OR model, the presence of a NOT indicates a deadlock. Deadlock in QR model, a process PI is blocked if it has a pending OR request to be satisfied. With every blocked process, there is an associated set of processes called dependent set. A process shall move from an idle to an active state on receiving a grant message from any of the processes in its dependent set. A process is permanently blocked if it never receives a grant message from any of the processes in its dependent set. A set of processes, S, is deadlocked if all the processes in S are permanently blocked. In short, a process is deadlocked or permanently blocked if the following conditions are met. Each of the process is the set S is blocked. The dependent set for each process in S is a subset of S. No grant message is in transit between any two processes in set S. A blocked process P is the set S becomes active only after receiving a grant message from a process in its dependent set, which is a subset of capital S. Next one is PQ model, that is P out of Q model. This is a variation of AND OR model. This allows a request to obtain any k available resources from a pool of n resources. Both the models are the same in expressive power. This favors more compact formation of a request. Every request in this model can be expressed in the AND OR model and vice versa. Note that AND requests for a P resources can be stated as PQ and OR requests for P resources can be stated as PL. Next one is unrestricted model. No assumptions are made regarding the underlying structure of resource request. In this model, only one assumption that the deadlock is stable is made, and hence it is the most general model. This model helps separate concerns about properties of the problem, that is stability and deadlock, are separated from underlying distributed systems computations. Example, message passing versus synchronous communication. Thank you. I hope you all enjoyed this video and understood the topic very well. Thank you so much.